Okay, so I'm signed in to RHS1. I'm signed in as the student account, and I'm in my home directory. So what we're going to do is start working on links. So someone sent me an email in regards to I'm missing a file that the lab refers to. So in this section of the book, it refers to a file called newfile.txt. So if I do a list, I don't have that file. So I'm going to do touch new file.txt list, and now I have the file. The touch command does two things. I'm going to do a list long new file. If this file already existed, it would just update the access time. That's what the touch command is designed to do. If I do touch -- help, I can change the time if I wanted to using this format. So this -T switch. So I could do touch new -T 1857 November 1st. New file. I'm doing something wrong. At 12:57. So this is the year, this is the month, this is the day, this is the hour, military time, and this is the minutes. So new file. So this file was last used November 1st, 1857. So those timestamps, you know, you hear a lot about this forensic stuff, is really irrelevant. So the purpose of the touch command is to update the time. But if the file doesn't exist, it creates it. So if the system refers to a file that doesn't exist, like this lab that we're doing, touch it, and then you'll be good to go. Okay, so I have this file called newfile.txt, and there's one copy of the file right there. That tells me there's one copy of this file. Because what we can do is create something called links. We have two types of links, symbolic links and hard links. Sometimes a symbolic link will be called a soft link, and I'll explain the difference between those two. So first thing I'm going to do is do a hard link, and I'm going to specify ln for the link command. The source file and the destination will be the temp directory, new, and just to make this clear, hlink2.txt to stick with what the book is doing. So basically, I have this chunk of data on my hard disk. And when I look at my directory, this term new file points to that chunk of data. So now I'm going to have two pointers pointing to that chunk of data on my hard disk. This will point to that chunk of data, and this will point to that chunk of data. That's a hard link. Basically, two pointers to the same file. As long as one of them exists, that file will still exist. Okay, So I'm going to do list long new file.txt. So right now I have a 2 right here that's telling me that there's 2 pointers to that chunk of data, the actual text file. I'm going to echo something into that file just so we can see it has some content. So normally, if I type this, it comes out on my screen. Here, I'm redirecting my output to that text file. So it's going to insert the word something into that text file. If I cat the text file, I can see it has something in it. If I cat the other link, it also has something. If I echo something else into this file, and I cat the other file, I can see they both have the same content. So both files point to the same, both of these directory entries point to the same file. That's a hard link. There are limitations to hard links. A hard link can only exist on the same partition. There's a I know discussion in the book. You can read that. But if there are if there's a hard link, that hard link can't cross different partitions. It has to be on the same physical partition. But I've had this discussion with a bunch of other people. You know, nowadays we don't really have a lot of uses for hard links. If you want to back up a file to make sure no one accidentally deletes it, you can do a hard link, and that's going to make sure the file still exists. So right now, if I delete this file, this one right here, as long as this exists, I can still access that file. So I'm going to delete that. RM to remove that file, and then I do a list temp new file. Kind of think of a hard link as 2 pointers to the same file. Now if I do a list long this, I can see there's only 1 pointer to this file. The other type of link that we have is a soft link. So I can do, I'm going to remove this, temp, new file. So I've just deleted the last pointer to that file. You can actually see inodes by doing a list-I, but I'm not going to go get into an inodes discussion. So I'm going to create this file again. What is this command going to do? No, let's do this. If I type history, how can I rerun this command? What do I type to rerun that command? Put it in the chat box.
Is that
Okay.
bang 42?
Yes. So bang 42. Just a reminder, if you talk, it will be part of the recording. As long as you don't care, I don't care. So that's going to recreate this file. There it is. Now I'm going to do a soft link or a symbolic link. I'm going to, the source file is new file, and the destination where the soft link will be new file softlink.txt. So if I list long new file, I can still see there's only one pointer to that chunk of data, to that file. So this link right here points to this link. This link points to the actual file. So if I delete this, this will point to nothing. So, you know, there's actually going to be an issue if you delete the original file. If you delete the original file, at that point, the link won't do anything. It's just going to point to another link, and that link normally would point to the file. If we delete it, it's gone. There'd be no way to access that file. But the benefit of doing a soft link over a hard link is it can cross different partitions. Because it's not pointing to a chunk of data on the hard disk, I can point this pointer to a pointer on another partition. So you don't have that benefit with a hard link, but you do with the soft link. It can go across different partitions. You'll come across links every once in a while. If I do a list -long to the root directory, here's a link right here. Here's a link right here. Here's a link right here. So I can do a link to a directory as well. So I'm going to make a new directory, new dir, and I can do a link symbolically. The source is new dir. This other directory, it's going to be a relative path, will be new dir soft link. Now list long. So if I go into this directory right here, it'll actually take me into this directory. So I'm going to cd into new dir soft link. If I touch a blank file, if I go up one level, then down into new dir and do a list, I can see the blank files there. So anytime I do anything in this directory right here, I'm really making a change to this directory. So you can link directories or you can link files. So I'm going to go to the next chapter, the next section. The next section is a lab. Lesson 8 is a lab that you're going to be doing. Again, if any of the directories or any of the files aren't there, you can create them. So I can see that in your lab, it wants a directory called files. I don't have a directory called files, so I can just make dir files. And if it wants me to create a file inside of that directory, I can do touch files, and the file that they want is source file. So you can make any directory structure or any files that you want. So someone had moved ahead in the lab, that's fine. Okay. Here's a lab that confuses a lot of people. We're on lesson 9. Lesson 8 is a lab that you're going to do. Lesson 9 is something we're going to do together. I'm going to remove -rf new dir. If I list long, this directory, this soft link that pointed to that directory doesn't exist. That's why it's blinking red. So I'm going to remove that as well. I'm going to remove that file. Now we're going to do something called shell expansion. So I'm going to create a bunch of files so we can look at them. I'm trying to think of the best way to do this without confusing you. I'm going to make a directory called working. I'm going to go into that directory. I'm going to, for I in, this is easier to read on the screen, so I'm going to use this syntax, sequence 1 to 200. I'll explain this in a minute. Do touch video $I .mpg. Done. List long. Okay. Guys, if I run this command alone, sequence 1 to 200, all that command does is print out the words 1 to 200. That's all it does. Spits out 1 to 200. So I'm going to go back to this command. I had it in 3 lines. I had hit enter here. I hit enter here, but when I go into history, where I hit enter, it put a semicolon. So it puts it all back into 1 line. So I'm going to do a for loop. And the elements in the for loop is going to be 1 to 200, because this is just going to spit out 1 to 200. What I'm basically saying is execute this command, because I've enclosed it in $ brackets, before executing the outer command, which is a for loop. So the first time through the loop, for will be 1. The second time the first time through the loop, I will be 1. The second time through the loop, I will be 2, then 3, then 4, then 5, all the way to 200. So basically I'm going to, first time through the loop, touch video 1, $I is referring to this variable, and the first time through the loop, I will be 1, so it'll be video1.mpg, then video2.mpg, it's created a bunch of blank files, video1.mpg through video200.mpg. If I list, I can see them all. So I'm going to do another loop for I in $ bracket sequence 1 to 200. I'm going to hit the enter key. Then I'm going to say do. Everything between do, the word do and the word done is going to be part of my loop. So I'm going to say touch picture 1, $I .jpg. Done. So it's going to create picture 1, picture 2, picture 3, all the way to 200. If I list my directory, I create a bunch of files. Okay, so I can do list p asterisk. So that's going to show me all my files starting with P. It's going to, this is called shell expansion. That's a wildcard character. I can do any file that starts with picture and has a 1 or 2 as the next character, .jpg. Now, this is any one character. So basically, it's going to show me picture 1 and 2. It's not going to show me 100 or 101 because there's 2 characters here that I'm not accounting for. So if I wanted to see any file that was started with the 1 or 2 and had any 2 characters after it. So this will be 100, 101, 102. This won't show me picture 1 or 2 because there's no character after that. It ends in JPG. This will even include 200 because it fits that criteria. It has a 2 and then 2 characters after that and ends in .jpg. How are we doing with that so far? I'm looking at the text. Okay, so the next thing I'm going to do is I'm just going to create a bunch of files just to match what the book is doing. Touch, Alpha, Bravo, Charlie. Every once in a while, guys, in this virtual environment, when you type a character, it might print it a bunch of times. So when I hit space command, it hit a bunch of spaces. Delta, Echo, Able, Baker, Cast, Dog, Easy. So I have several files here. I want to see all the files that are only 4 characters long. Sorry. List 4 characters long. I want to see files that are 3 characters long. 3 characters long. Okay, I want to see what did this do? So what is this going to display? Videos 1, video 1.mpg, video 2.mpg, video 3.mpg. If I hit enter, it's going to show me those 3 videos. I could put, this is called the caret symbol, which means not. So basically, I want to see any video that has the word video, any one character that's not a 1, 2, or 3, and ends in .pmg. So this will show me 3, 4, 5, 6, 4, 5, 6, 7, 8, 9. It won't show me 10 because 10 has too many characters here. What if I did this? The same exact thing. I'm going to do for I in sequence 1 to 200, do touch videos $I .jpg. Well, whatever. No, let me do that again. MPG done. I could do it all in one line. Okay, I press Control C to cancel that command. List videos, video digit asterisk. So that's going to be any file starting with the word video, and the next character is a digit, not a alphanumeric, and then anything at the end. So that won't show me any file that has videos. So I could say alpha. So that's going to show me all the videos, plural, but not show me anything that is video then a number. This is an interesting one. I don't use this often. List tilde. What is that tilde normally do in regards to your home directory? Does anyone? I could do CD tilde and I can go to my home directory. So if you do a list tilde and then the user account name, it will list everything in that user account's home directory. Clear. I'm going to go out of my working directory and delete it. And this will delete all those files. So basically what I did was I went up one level, which brought me back from the working directory to my home directory, and then I deleted that directory. If I do make, now that was shell expansive. Now I'm going to, that shows you how to filter out certain things. And I used square brackets to do that. This is not a really good example. Let me think of a better example. Now I'm using curly brackets. And I'm separating the elements in this. So that created week 1, and these are squiggly brackets, 2, 3, 4, and I can see those down right here. Let me see if this will work. Make dir week sequence 10 to 100. List long. No, it didn't really work. But it was worth trying. Let me try something else. No, it's still not working. Okay, but so if you want to create multiple elements, I could do something like that. I could do I could also do this with the touch command. Video 1, 2, 3, 4, 5 list, and it created those 5 files. So if you have to make a bunch of directories or a bunch of touch a bunch of files, then at that point I could just use those brackets. Guys, I was testing something here, it didn't work. I was testing something here and it didn't work. I wanted to see if I could do a double execution. So basically, anytime you see the $, one bracket, and then a $, a $, bracket, some command, then then another bracket, that means execute that first before executing the outer command. It didn't work in those cases, but I tried. Okay, so now I'm going to play around with the variable. Brian equals person. Echo $ Brian. So you can set up a variable by saying the variable name and what it equals. I could do the date equals and here I'm going to execute this command. It's going to replace this with the actual date and save it in that variable. Echo $, and there's the date. So it could be, I could have some output of a command be saved in a variable as well, and that's what I did right here. Generally, if it's uppercase, it's an environmental variable set by the system. If it's lowercase, it's something you created ad hoc. If I type env, it shows me all my environmental variables. So these are variables set by the system when you boot up the machine, like my current user, or when you log in. My current user account is student. So now I can echo $ user and get the value for that variable. These are all set by the system. So if I'm just using a variable just temporarily for some script that I'm writing, I probably would keep it in lowercase. So my var equals something. $ my var. Sorry. Echo my var. And basically, this is just like an ad hoc variable. Guys, when you use a variable, you put the $ in front of it. When you set it, you don't put the $ in front of it. And they have some sort of elaborate example in the book, which is kind of nice. Echo today's is date plus %A. So again, before it runs the echo command, it's going to run this command first. Replace the output of that with Tuesday. This will be replaced with Tuesday. Then it's going to echo today is Tuesday. I'm going to create a variable called today. echo $ today. Echo today is today. Same. If I enclose it in double quotes, it still works. But if I enclose it in single quotes, it doesn't work. So double quotes will resolve a variable to its value before echoing what you're doing. If I enclose something in single quotes, it's absolute. I'm saying this is not a variable. I want you to echo $ today. So that's an absolute value. Normally, when the shell sees a $, it's going to assume anything after it is going to be part of that variable name until the next space. I can interpret by using the escape key. Normally, the shell sees the $ symbol as the beginning of the variable name. But by escaping in front of it, I can't highlight. By escaping in front of it, I'm going to tell it to interpret the $ differently. So now it's just going to interpret that $ as a regular character, a printable character. It's not going to interpret it as a variable, as the beginning of a variable. Okay, guys, want to start the quiz? Which pattern will match only file names ending with B? I'm watching the chat. Yes. Wildcard B, ending in B. Which pattern will match only files beginning with B? Yes. Which pattern will match only file names where the where the first character is not B? You can use bang or caret to indicate not. Which pattern will match a file name containing a B? Okay, let me ask you this. Could the B be at the beginning? If I choose this as my answer, will this match if the file started with B? Yeah, let's look at that. That's kind of an interesting thing. So I'm gonna touch a file called Brian. List *B*. Yeah, so it will work for something beginning in B because essentially that wildcard character will match anything. Okay, which pattern will match only file names that contain a number? Yes, no, you got it right but you're missing those asterisks. It has to be something, a number somewhere, something. Which pattern will match only file names that begin with an uppercase letter? I didn't go over this, but yes, it has to begin because I didn't put that asterisk in front of it. Which pattern will match only file names at least 3 characters in length? at least. Yes, 3 characters, wildcard. Okay, now this is a lab. Lesson 11 is a lab. Lesson 12 is just kind of like a reminder of the things that we did in this thing. Now we're going to move on to lesson 4. 4 is a real easy chapter. So guys, if you are in a jam and you need to find something out about a command, what do? How do you go about getting help for a command? And most of us generally are going to navigate toward Google, and I'm going to do man. I hope this doesn't come up with something. Okay. So I'm looking, that man stands for manual page. Linux was released under this license, the GPL license. The GPL license was created by Richard Stallman. And Richard Stallman, this is what made Linux what it is. You know, you can say a lot of things about, oh, the kernel with, yeah, that could have been a bad search term. But, you know, you can say things about Linus Torvalds and the kernel and the GNU creating all the other stuff around the kernel. But this is really what made Linux. And it was created by Richard Stallman. So basically this Linux, this license agreement, basically they call it copy left, not copyright. Because basically when you license something with the GPL, you're telling the person who gets the product, the software, that they are allowed to take that software, they're allowed to make changes, they're allowed to give it away to anyone they want, but when they do, they have to give it away under the same license. So, and the person who originally created the software is also not liable for any damages done by using that software. So what this did was it allowed people to take a piece of software, write it, give it to the community, and at that point, they wouldn't be allowed to change the license and make money off your product. Because at one point in time, Richard Stallman had a piece of software. He wrote it. He gave it to his friend. His friend made some changes, then sold it to a company. Now at that point, Richard Stallman wanted to make additional changes, and he couldn't because now it was sold to another company, and they owned that product. So he wanted to prevent this from happening in the future, and he came up with this license. The other thing that this license did was it said when you release this software, not only do you have to give the source code for the software, so someone else can make a change. Give me 1 second. Okay, but not only do you have to give the source code every time you release a piece of software, so someone can make changes to it, you also have to release man pages. And that's what this stands for, manual pages. So basically, you need to describe how to use that piece of software. And in that man pages, there are multiple sections. So you have section 1, which is user commands, section 2, system calls. So you can see if that has any interaction with the kernel, library calls, any special files that it needs, file formats. Normally, section 6 will be a little, does anyone know what an Easter egg is in software? They used to like have Mindhunter or something built into software. So if you go into like Word, there'd be a little embedded game hidden. Well, that started out here, and basically in the man pages, they would have a little game. 7 was miscellaneous stuff. 8 was for like administrative commands. Like when we had this command IP, like IP adder, there's things that normal users can do with this command, and then there's things that the root user can do with this command. That would be under section 8. And then section 9, you would have some sort of kernel routines. So if I do man touch, it's going to show me section 1, which is what a normal user would need for that command to know how to run that command. If I do man 7 touch, there is no section for man 7. So this section is blank. Let me do man IP. So by default, it shows me section 8. I'm hitting Q to get out of that. And if I do man 1 IP, it doesn't have any section. So not every command has a section for everything. But when you type man and then a command, it tries to show you the most appropriate section, but there only might be one section. So according to the GPL, they need to release these man pages with every piece of open source software. How many people use Android phones? And are you aware that Android is nothing but a Linux? It's a Linux with a graphic front end on it. But how many people use the man pages on their phone? So even though it says you're supposed to release the man pages, it is perfectly acceptable in small embedded devices like phones. Even your iPhone is Unix, and it uses a lot of open source software. You know, a lot of embedded devices, they don't put the man pages in the product itself. They're relying on you going to the internet to get the man pages. So a lot of man pages are out on the, right here it is. Like here's some man pages, and there's a bunch of websites that have all the man pages out there that you can go to. And so here's a nice section for I guess this is no, this is just a description of the man pages. But there's a lot of websites that have the actual man pages out there that you can go to. Like right here, die.net. You know, talks about the various sections. Then you could jump into like I and look at all those commands. So this is from section 3. Now I'm going to go into this man page, guys, and I can scroll up. Using the space bar. I can use the arrow keys and go up and down. There's 203 lines here. So this is the documentation on how to use the IP command. And there's a lot of documentation here. If you want to leave the man page, you can hit Q for quit. And if you want to get additional help, you can hit the H key and it'll show you how to navigate in man. If I hit Q, it'll get out of the help. Q again will get out of the man. They also have the info pages. I never, guys, and if you read the book, they tell you how to navigate and search and do things like that in the man pages. They also talk about the very top, what these sections mean, like name, synopsis, option. If you go to the very bottom, you will get who wrote that piece of software, how to report a bug if there's a piece of software, things like that. So there's a lot of things in the man pages. I could do a search for a man page with this word in it. Let's say I don't know the command, but I know it has something to do with the password. There's nothing appropriate. I'm sure there's something with the word password in it. You'll come across different versions of man. Sometimes man will not be compiled with the K option, so it won't work. So if you have one of those distros that does support the K option, so basically it hasn't sorted, it hasn't searched and created that little database, so it knows what it's called appropriate. Basically, you're searching for a command that has password in it. But you'll notice that not every man is compiled with the K option actually functioning. You know why? Because we don't really use the man pages a lot. You know, they've come out of favor because now we have the internet. A lot of times you'll see that we just look at help or look at the internet. And I'll show you how to get to the help. If I hit uppercase K, it'll do a manual search for anything with the word password in it. Where if I look at lowercase k, that looks in the appropriate database. That's what it's called, appropriate database. The database name is appropriate. It just doesn't have that database compiled. And basically they didn't include that in the command when they compiled it. Because when Red Hat made this OS, they took the source code for man that was released in the community and then recompiled it when they built this distro. Okay, guys, lesson 2 is a lab. Now, the GNU people also created something called the info pages. I can go there, or I can do this. So I'm just going to do pinfo. Guys, I've never professionally used the info pages. 1 second, I read a question. Okay. yeah, someone said that that was a man page on how to write a man page. So here's some sort of little utility. I'm going to press Q to quit. P info. So I'm going to look up information about tar. And it's like this little, I don't want to say graphic, but more interactive info page that allows you to use your arrow keys and jump to the different sections. So if I want to jump to the tutorial section, I can highlight tutorial and jump to that section. And then here's more sections, how to create, how to do things. If you want to go back, you can go escape, maybe. Again, I've never used this, so I'm not sure how to get back. I'm sure there's a way. Give me a second. Let me look and see if the book has it. Uppercase U. Yeah. Uppercase U brings you back to the parent node. See, right now, I'm at the parent. Will take me back one level. I went too far. Sorry. So if I go into tutorial, the parent node is the main node. If I go into create, the parent node is the tutorial. So you can uppercase U to go back one level. So it's a way to have a more interactive help screen. I guess that's what you'd call it. And the next lesson is a lab, which you're going to do. And the next section is a lab, which you can do. And that's the end of that lesson. Guys, also I want to point out something here. I hit Q to get out. Before there was P info, there was regular info that you could go to. And it's, again, more archaic, but it had the same menuing system that you could go to, but you just use your arrow, highlight the thing, hit enter. Again, uppercase U will get you back. Q to quit. So there's info as well, but again, I'm not real big on P info or even the man pages, because most of the time I just go and do this. tar --h. If it doesn't support --h, it might support -h. So that's another way to get some help. Okay. Guys, it's at the top of the hour. We're a little bit past. So we're going to take a 10-minute break. And then the next section is going to be editing text files. This is the thing that scares people the most. So let's take a 10-minute break. We're going to come back at 7:32, and I will see everyone in 10 minutes. I'm going to pause the video and okay. So before they actually start talking about the VI text editor, they start talking about output redirection, or actually redirection in general, input and output. So normally if I run this command, the output comes to my screen. I can rerun it and redirect it to some file. Sorry, I was repeating characters. So if I cat that file, the output didn't come to my screen, it went to that file. We normally just use greater than symbol, but in actuality, it's a 1 greater than, because that means output redirection, greater than, a 1 greater than, or just greater than. Now, I could cat this file, etc password. When I cat a file, the output comes to my screen. So I can redirect that to another file. If I cat it, it would be essentially a copy of that file. Or I can cat 2 files and join them together and save them in one file. etc password, etc group. Don't worry about what files I'm catting. It's not really important. So now if I cat this file, it will have both etc group and etc password in the same file. If I do cat, no, I'll do this. I'm going to do date into another file. If I cat another file, it's going to overwrite everything that's in that file. So even though I had etc password, the contents from etc password, and the contents of etc group in that file, when I did this command, it erased the file and overwrote it with the date. If I do 2 greater than symbols, and I'm going to cat that file now, it will append. So 1 is append. No, 1 is replace, 2 is append. What if I did this? Cat etc group, then I made a mistake and said etc and I spelled out the full password. Well, etc group exists. That's a real file. etc password is not a file. So I have 2 things on my screen right now. I have standard out, my standard output. Then I have something called standard error. So if I echo $, this is called a shell parameter, $, question mark, it will tell me the return code of the last command that I ran, and it returned a 1. If it returns a 0, that's a normal, the command executed no problem. If it returns a number, anything other than 1, that's a problem. Has anyone ever written a C++ program and at the very end of your main section, you put a return 0? Well, that's what this is reading, that return value in your program. So what I can do is cat etc group and etc password. Again, I'm spelling password wrong. I'm going to send standard output to a file called out file. Now I'm going to do 2 greater than and send my errors to another file. So 1 greater than, or just greater than alone, is standard output. 2 greater than is standard error. So if I cat out file, it will show me the contents of etc group. If I cat errors, it will just show me the error code. Let's say I don't want to save that error code. I want to cat these files, and if I get an error, I don't want to see it. I can redirect my errors to a device called dev null. Remember that the device directory holds my device drivers. I have this weird device called a null device. Anything you send it gets trashed. Back in the day, we would call that a bit bucket. Anything you don't want to see, you just drop in your bit bucket. So this will save all the output to a file called out file, and then any errors, it will send to dev null and make them disappear. So if I cat out file, let me remove this RM errors. So I don't have that. So if I run this command, again, I don't have an errors file because I didn't create it. I'm hitting the tab key, nothing's there. But if I cat my out file, I can see it has Etsy group. I could do something like this and append. And that will append to the out file. I could go back to this command and do append here. Not that one. I'm hitting the up arrow to go through my history. If I run it again in cat errors, you can see it showed the error twice because instead of overwriting, I'm appending. What if I wanted to send my output and the errors to the same file? I can certainly do this. I'm going to cat that file. Here is the error, and here is all the other stuff. Let me see something real quick. Head Etsy group. It's kind of weird because when I did it that method, it kind of corrupted the file because I'm missing some things. Look, I'm right here. It cut off all of this. And anyways, this is not the preferred method of sending the output and the errors, standard out and standard error, to the same location. The preferred method would be that's going to send my output to that file, but normally we don't see that one. Then I'm going to say 2, redirect to the same place as 1. You'll see that all the time. So now my out file includes the out, standard out plus standard error. Or I could do this method if I didn't want to, because that's a lot of typing. Incidentally, that method I just showed you was the most common, but this works as well. This will send output and error to the same location. If I wanted to append, sorry, I could do that. If I wanted to append with this method, I could do that. Oh, no, actually, I don't think that'll work. I can do this. That will append to the file. Okay, so what's the difference between what I just did and cat Etsy password pipe to grep for root? What's the difference between that redirecting my output and the pipe command? Does anyone know? Here, I'm redirecting to a file. When I do a pipe, the output of this command becomes the input for this command. So when you pipe to another process, another command. When you redirect, you redirect to a file. So if I did tell, I'm not signed in as root, so I'm limited to what I can do. Etsy tell-n1, that's going to give me the last line of Etsy password. I could let me try to do something longer. If I do, I'll just cat Etsy password, and I pipe it to more. So what that's going to do is it's going to, the more command does one page at a time. It's probably not the most efficient way to do this, but it'll work. So I'm going to cat this, and that will become the input for the more command and allow me to go one page at a time. In reality, it'd probably be more efficient to do this. But I'm the type of person, I just always do that anyways. There's a command that allows me to send my output to a file and display it on the screen. So I'm going to do T Etsy cat Etsy password, send it to the T command, so what it's going to do is it's going to take the contents of Etsy password, send it to this file, and also display it on my screen. In this particular case, the output of this command is going to go into the T command. The T command is going to split it off into two streams, one to a file, one to my screen. So if I cat some file, I can see it has Etsy password in it, the content of Etsy password. Okay. Quiz time. Which answer displays the output to a terminal and ignores all errors? I'm looking at the chat window. What would you append to a command to look at the output, but any errors that you get, trash them? Do you don't know, or is no one listening? Okay, good. So 2 greater than is errors. I'm going to send it to the bit bucket. Which command sends the output to a file and sends the errors to a different file? D. All output will go to file all errors will go to file 2. Which answer sends both output and errors to a file and creating it and overwriting its current contents, or its content? This is confusing, but that's not right. It doesn't really do anything. It's not to, and that doesn't really exist. This right here will overwrite your current file because it's only one greater than symbol, and it's going to send output and error to the same file. So D. Which answer sends output and errors to the same file, ensuring existing file content is preserved? D is going to append and send to that file to the same place as 1. Which answer discards all messages normally sent to the terminal? I didn't kind of go over this, but you can figure it out. Instead of having any output at all, it's just going to send it out. It's just going to trash it. So this will send errors and standard error and standard out to dev null. A. Which answer sends output to both screen and a file at the same time? B. Last one. Which answer saves output to a file and discards error messages? Output is going to a file. Standard error will go to the bit bucket. This will send everything to the screen in a file. Then if this command has any errors, send it to there. But that's not going to work because the errors were over here on the pipe. Remember, when you pipe, the output is sent to become the input of this. Any errors that you get over here on the output, let's look at that. So I'm going to cat some file. No, let me echo date into some file. So it's not what I wanted, but look. So if I cat some file, it only has the word date in it. So I'm going to cat this file, date, and also cat this file that doesn't exist. So that generates some output and some error, standard output and standard error. So I'm going to pipe it to T. No, I'm going to pipe it to grep. That's not a good one. That's gonna. I'm trying to think of another. Let's see if I can do echo. no, I don't want to say T. I'll just do this. So I'm going to cat this file. It will generate some output. Then it's going to also generate an error. I'm going to take the output of this, which is only the date command, because this is an output, and send that to T. So the pipe won't send errors across, won't allow errors to go across and become the input here. If this generates an error, that's where the error is going to be displayed. It won't have any effect on anything after the pipe. Anything here isn't going to get that error at all. So the pipe doesn't send standard error going across. Hope that makes sense. So this isn't really going to, but if this command generated an error, that will catch the error generated by T. It won't catch the error generated on the other side of the pipe. So our answer is the top one. Okay. Now we're going to deal with VI. So let me go back to my machine. I guess they do it uninstall. Maybe it's an alias. Let me see how they handle this. Okay, so they do it with an alias. Guys, back in the day, we had a command called VI. VI didn't understand this portion of your keyboard. Let's see if that'll work. Let me see if I can get my camera to focus on that. You see how I have a number pad on my keyboard? VI didn't understand that. So if you wanted to navigate, you had to use like I, J, K to move up and down. So if you install Ubuntu, it installs VI. So if you try to hit like an up arrow or something, it generates a weird error. But in Red Hat systems, they don't even install VI at all. It automatically installs a program called VIM. So when you look at the book, they tell you to run VIM. But when you do, you're really running VI. If you're in an Ubuntu box that had VI installed by default, and then you went and installed VIM, it will do something called alternatives. This is the way Ubuntu does it. So when you run VI, it'll actually run an alternative program called VIM. The way Red Hat does it is, if you run VI, it's actually running a command called VIM. So when I keep referring to VI, I'm going to be referring to VIM, which is VI improved. VIM will understand the arrow keys. You can use up and down. It'll use the number pad on the right. It'll understand the arrow keys that we have on our keyboard, where the old VIM doesn't understand that. So just be aware that we're going to be using VIM. So the book keeps telling us to type VIM in the file name. Well, I don't need to do that because we have that alias in place. You might not have that in place when you take the test. So if you type VI and nothing shows up, then you know why. Guys, I'm trying to arrange my other windows, sorry. So I'm going to do VI and a new file, .txt. Every book kind of has this a little bit different. The way they call these modes are a little bit different. Right now, I'm in a mode called command mode. Anything I type is a command. It's not going to be a printable character. So if I want to go into insert mode from command mode, I hit a lowercase I. So anything that I type now will show up on my screen because I'm in insert mode. There's a kind of a lag when I type. Now to get out of insert mode and go back to command mode, press escape. But if we really want to get technical, what lowercase I does is doesn't just put me in insert mode. Notice I'm on the T character of that third line. Okay, and also these little tildes right here represents nothing. That means there's no blank line at all. If there's no tilde there, that means it's a blank line. So this is nothing, this is the blank line. So I'm right now in command mode. I'm going to press a lowercase I. And when I type, do I type before the T or after? I'm before. So when you type a lowercase I, it inserts you before your current character. So right now, I'm going to press escape to get out of insert mode. So I'm right now in front of L. So if I hit I and I start typing, those characters become before the L. I hit escape to get out of insert mode to go back to command mode. If I hit a lowercase u, it undoes it. Anything I did in the last insert mode is removed. Okay, I'm going to now do a lowercase. So let's so I'm pulling up another thing. Okay. So we did a lowercase I. These are things you're going to have to remember. These are common ones that I use all the time in VI. There's a whole bunch of things that you can use, but I'm going to go over in the book also goes over the very common ones. So I'm going to hit I'm on the L key. I'm going to hit, and I'm in command mode. I'm going to hit a lowercase a and then start typing. So a lowercase a puts me in insert mode after my current character. So they both put me in insert mode. This is before my current character, after my current character. Now I'm going to press escape to get out. Hit U to undo. Okay. So now I'm on the I character. I'm going to hit a shift I. That puts me in insert mode before my current character. So I'm going to press escape, undo it. So there's really a lag going on here. Okay, I'm on the A character. No, actually, I'll go to the T. If I hit an uppercase A, it puts me in insert mode at the end of the line. So these are common ones I use all the time. Press escape to get out of insert mode, U to undo. YY. That stands for yank, yank, yank. I'm going to write it here. I don't know where they got the name. You know, it's like you yanking something, pulling. So I'm on the second line, I'm going to do a YY. It appears, nothing appears on your screen. But what I did was I just copied that line. Go, give me 1 second. Yeah, the book kind of jumps around with the VI stuff, and I'm trying to. Yeah, the book doesn't really go into VI at all. I mean, it's just superficially. Okay, we'll still go through it. Guys, this is important because I use VI all the time. Yeah, the book doesn't really go into depth in VI at all. Maybe in the second book it does, but you still need to know it. So guys, I did YY. I'm going down to the third line. So I copied this second line, yank. YY is yank. So I'm going to go down to the third line and hit a lowercase p. So what it did was it pasted that line after my current line. So I'm going to undo that. I'm going to copy the second line again, YY. I'm going down to the bottom line. I'm going to hit an uppercase P and that paste above. So lowercase p will paste below. And uppercase P, it's hard to see in this text editor, paste a lowercase p, paste below, uppercase P, paste above. YY will copy. Keep in mind during all those commands, if I hit a lowercase p, I still say in command mode. I don't leave command mode to go into insert mode. So YY, P, or lowercase p or uppercase P keeps me in command mode. Now I'm going to take this third line and hit DD. go to the very end and hit a lowercase p. DD is cut, not delete, cut. It puts it in memory. So I can paste it somewhere else. So if you want to cut a line, DD. A lot of times, guys, I'll just hit DD, and at that point, just keep with D, you know, and just keep moving along and never paste it anywhere. So a lot of times I use it as a delete just because I never paste it. So if I hit DD, then DD again, at that point, I'll overwrite the first thing I cut. So if I hit DD here, I'm going to go to the first line, hit DD, then DD again. If I hit paste, the first line is gone. P doesn't stand for paste, P stands for put. Okay. A lowercase x. I'm still in command mode. If I go to this character and hit a lowercase x, it keeps me in command mode, but it deletes that character. So X is really delete one character. So now what I'm going to do is show you something called extended command mode. So if I hit colon, it brings me to the bottom. And there's all kinds of things I can do down here. Let's say I hit a forward line, a forward slash, and I type line. That will do search. So hit line. If I hit N, it will go to the next line. You know, the next occurrence of the word line. Hit N again. If I hit Shift N, it'll go backwards. So that's equivalent to find. If I hit a question mark, then line, that does the same thing as backslash, as slash, but it searches backwards. So in extended command mode, this and this are same as the find command in Notepad. If I go hit a colon, go back to extended command mode, hit $S, %S, one word slash another word will replace, will be essentially like find and replace. If I do S, %S with no G at the end, it'll only replace the word line with word on my current line. If I use G, it'll mean global, saying do it throughout the document. So in a case like that, I just replaced line with word. So it'll be %S, word to replace, or words, I'm trying to move this over, and what you're going to replace it with. And the G at the end means global. So that's equivalent to find and replace. I'm going to go back to extended command mode. I'm going to hit the bang key. This will tell me to execute a command in the shell environment and come back to VI. So I'm going to say cat etc host. So I'm going to cat a short file. It shows me the file that I just catted. And when I hit enter, it goes back to VI. Let's say I want to take that output of that command and put it in this document. So I'm going to go colon, read, bang, cat etc host. Hit enter. Not only will go out and execute a shell command, it will come back and insert that text into my document at the very end. I don't know if it's at the very end. It might be anywhere my cursor's at. I'm going to hit colon to go down to extended command mode. Guys, and I can use my arrow keys here to go back through the last commands. No, it'll insert it right after my cursor. So wherever my cursor's at. I'm going to press escape. So I know I'm not in insert mode. If I colon to go into extended command mode and hit W, it will save this file. If I hit colon WQ, it will save the file and quit VI. I'm going to go back up and rerun that command again. Colon Q bang will exit the file. If you made any changes, but you don't want to save the changes, you would type Q bang, and that's like quit but force. I'm going to go back into the file. Sometimes, guys, when you're signed in as root, the system could block you from saving a file. But as root, you can force it to write to the file because you're root. You can do anything you want. So I can hit W, bang, and that will force write. I could do W, bang, Q, that'll force write, then quit. Okay, guys, you can go to a search engine and type VI cheat sheets, and there's hundreds of them out there. This one I look at all the time. This green one I look at all the time. So if you can go, this one, guys, is very detailed, but it's almost impossible to read. You know, they talk about the arrow keys and all the things that it can do, like Y is yank, U is undo. It's too difficult to read. Go with this red one. It's relatively simple. It tells you all the things that you can do with VI. Delete the current character. 5x will delete 5 characters. Delete to the beginning of the line. It's extremely powerful. Right now, just get used to using VI, doing simple stuff. Another thing is, guys, instead of doing colon WQ to get out, from in command mode, I can type uppercase ZZ. That's the same as save and quit. So instead of doing colon to get into extended command mode WQ, I can hit, I just deleted till I went back into command mode. I just pressed the delete key. Like I had WQ here, I hit delete, 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 and that brings me back to command mode. Uppercase ZZ will do the same as colon WQ. Okay, guys, this is where I'm going to stop for the day. I don't know how well I did with that VI. You know, it was kind of short, but we'll see how you play around with it. You'll get more practice using VI when you start creating a document. So I'm going to do something very simple. I'm going to create a document called My Script, and this is what I want you to do to practice using VI. So I'm going to go here and create a script called myscript.txt. No, .sh. So we're going to create a script. And then I'm going to go into insert mode. Shebang. That right there, hashtag bang, we call it shebang. So I'm going to start my script with shebang, bin, bash. That lets the shell know when they execute this script to run it in bash. If I had shebang, bin, Python, it knows to execute that script with Python. So this is going to be a bash script. So echo $1, echo $2, echo $0, echo $. So I just created a simple script. I hit I to go in insert mode and I type that stuff out. I'm going to press escape to get out, colon WQ to write quit. Now I need to make that script so I can execute it. Don't worry about what I'm doing right now. Just run this command and it'll work. Now let me do that differently. So I'm going to run my script after I turn it into execution. I'm going to run my script and put 2 arguments after it, my name. So I'm going to cat the script. These are called shell parameters. $1 is automatically assigned to the first argument. $2 is automatically assigned the second argument. So this says echo the first argument, echo the second argument. $0 says echo the name of the script. $number says echo the number of arguments that I have, 2. So I want you to create a script similar to mine and use VI to do it. Just give you something to practice with. Save the script, and at that point, turn it into an executable script, then execute it. Just to give you something simple to do with VI. Because as a system administrator, we're not going to use VI to write Going with the Wind. We're going to write text files. No, Raphael, sorry for using your name. No, you don't have to do it right now, but whenever you practice VI. Just get anything you want to type. It could be a text from the book and start playing around with it. The only way you're going to get familiar with VI is use it. So right now I'm going to stop at this lesson, which is lesson 5 of chapter 5. We're almost essentially done with this chapter. Play around with VI, and then we'll meet again on Thursday to go over the rest of this stuff. Guys, if we look at the syllabus, I kind of have a guideline of what I'm trying to do every week. So if I go to the syllabus, which is this one right here, the first week we were a little bit behind. This is where I should have been done with the first week. So I'm actually getting done with that today. It took us a little longer to get started. So this is what I want to try to accomplish on Thursday. It's not that bad. You know, creating users and groups is the longest part. We'll see how far we get. Permissions could be a little bit scary, but we'll deal with that. This is kind of a guide of where I want to be every week. So guys, I'm going to give you permission denied. I'm going to stop this recording and answer your question. I'm going to pull up your lab. So I'm going to stop the recording. If you want to go, that's fine. If you want to stay and start working on this with me so I can help you with questions, we can do that now. So I'm going to stop the recording. It's going to take like an hour. Actually, it took 2 or 3 hours last time. Once it's done, I'll put the link up on the announcements.